Question 4, Part C. A chessboard has 32 black squares and 32 white squares. Tanya chooses 3 different squares at random. Part 1. What is the probability that Tanya chooses 3 white squares? We consider this situation as a 3-stage selection without replacement, as the same square cannot be chosen more than once. So the probability of choosing 3 white squares is equal to 32 over 64. This is the probability of choosing the first white square. We have 32 squares that are white out of a total of 64. Now we choose one white square. We now have 31 white squares to choose from out of a total of 63 for the second choice. And then in the third choice, assuming we chose a white square in the second choice, there are now 30 white squares to choose from out of a total of 62. So 32 over 64 times 31 over 63 times 30 over 62 is equal to 5 over 42, which is approximately 11.9%. Part 2. What is the probability that the 3 squares Tanya chooses are the same color? The probability of choosing 3 white squares or 3 black squares is equal to 5 over 42 plus 5 over 42, which equals 5 over 21. And that's because there is an equally likely chance of choosing either all white squares or all black squares. Part 3. What is the probability that the 3 squares Tanya chooses are not the same color? By the law of complements, the probability of choosing different color squares is equal to 1 minus the probability of choosing 3 squares the same color, either all black or all white. And that equals 1 minus 5 over 21 from part 2, which equals 16 over 21.